In April 2020, a C-130J touched down at Ramstein Air Force Base in Germany and hit the runway at nearly twice the force it was designed to survive. The descent rate was 834 feet per minute. The load peaked at 3.8 Gs. The aircraft bounced, climbed away, and the crew prepared to land again until they looked at their instruments and saw the numbers from the previous touchdown. They landed gently this time, taxied to the ramp, and shut down the engines. The damage was extensive. Buckled skin on the underside, cracked wing sections, popped rivets across the entire airframe. All 4 engines needed rebuilding. By any normal standard of aircraft maintenance, this was the last flight that plane would ever make. But it flew again 5 years later. That repair, $20.9 million, a new wing shipped across the Atlantic, 5 years of work, is only possible because of a design decision made in 1951 that may not have even been intentional, and it explains better than anything else why no one has ever managed to replace this aircraft. The C-130 was born out of failure. Korea, 1950. American troops needed supplies, and the aircraft available, the C-47, the C-119, World War II designs, needed long paved runways. The front lines had dirt, mountain strips carved into hillsides, sometimes barely 3,000 feet end to end. The Air Force drafted a requirement. 9 manufacturers received it. 4 immediately declined. What was being asked for seemed impossible. An aircraft that could carry 92 troops, land on unprepared terrain, slow to 125 knots for parachute drops, and keep flying on a single engine. At Lockheed, a 37-year-old engineer named Willis Hawkins put together a proposal. When he showed it to Kelly Johnson, the most celebrated aircraft designer of the 20th century, the man behind the U-2 and the SR-71, Johnson looked at the drawings and said, "If you sign that letter, you will destroy the Lockheed Company." They signed it anyway. On August 23, 1954, the YC-130 lifted off from Burbank after a ground roll of 855 feet. At that weight, that wasn't supposed to be possible. Hawkins later described his design process in one sentence. They took the dimensions of the largest piece of equipment on the Air Force's payload list, drew a circle around its cross-section, turned it into a tube the length of a railroad boxcar, and put wings on it. A container with wings. That's it. That simplicity turned out to be everything. Because the aircraft was designed around military cargo standards rather than around the aircraft itself, it accidentally became the standard. The U.S. Army started writing equipment requirements that specified cargo had to be air transportable in a C-130. Vehicle designers built to those dimensions. Pallet systems were developed to fit that hold. Within a decade, the C-130's cargo bay had become what shipping containers are to the sea, a universal measurement that everything else had to conform to. The more equipment was designed around it, the harder it became to replace. And then the variants started multiplying. Ski-equipped LC-130s began landing on ice in Antarctica, where temperatures dropped to -50 degrees Fahrenheit. There is still no other aircraft that can resupply those research stations. AC-130 gunships carried 105mm howitzers firing sideways out of the fuselage. A cargo plane turned artillery platform, orbiting targets for hours. Hurricane hunters flew directly into tropical storms. Aerial tankers refueled helicopters mid-flight. Electronic warfare variants broadcast signals into denied territories. Firefighting platforms dumped 3,000 gallons of retardant in under 5 seconds. Same airframe every time. In 1963, the Navy asked whether a C-130 could land on an aircraft carrier. The USS Forrestal was just over 1,000 feet long. A C-130 normally needed 3,500 feet to stop. A pilot named Lieutenant James Flatley was told it wasn't a joke. He touched down 150 feet from the end of the deck and stopped in 267 feet. No tailhook, no catapult. Over the following days, he made 29 touch-and-go landings and 21 full stops. The record still stands. Which brings us back to that cracked wing in Germany, and the real reason the repair was even possible. In most aircraft, the center wing box, the structural point where the wings and landing gear loads transfer into the fuselage, cannot be replaced. It is the spine of the aircraft. Replacing it would mean disassembling the entire plane. So when a wing box reaches its fatigue limit, the aircraft is retired. In the C-130, the wing box is mounted above the cargo cabin, bolted in place from outside. It is what engineers call a lifed article, a component with a defined operational limit that can be swapped out when it expires. On early variants, that limit was around 19,000 flight hours. On the current C-130J, the enhanced service life wing box is rated to 122,500 hours. When the wing box is replaced, the life clock resets to 0. The aircraft is effectively new again. No one knows for certain whether this was a deliberate design choice or a lucky consequence of building the fuselage as a simple box, but the effect is the same. While other aircraft age toward retirement, the C-130 gets rebuilt. While other airframes accumulate fatigue that cannot be undone, the Hercules sheds it. The replacements have come. The Advanced Medium Stall Transport Program in the 1970s tried to build something better and died quietly. Airbus spent billions on the A400M. Faster, more capable, technically sophisticated, Britain retired their C-130Js in 2023 to transition to it, and their own Air Chief immediately flagged a Special Forces capability gap the A400M could not fill. The Embraer C-390 is promising, jet-powered, genuinely competitive. It also needs longer, prepared runways, which is exactly the one thing the C-130 has never needed. Lockheed now quotes the enhanced wing box at a proven 122,500 flight hours. At typical military utilization rates, that is well over a century of service life. The current production model, the C-130J Super Hercules, will likely still be flying in the 2070s. Aircraft bought today will outlast the careers of everyone involved in designing them, flying them, and trying to replace them. Kelly Johnson eventually changed his mind about the Hercules. A container with wings, he came to understand, could turn into anything. The sleek jets he spent his career designing are museum pieces now. That ugly, slow, unglamorous box is still on the flight line, still landing on dirt, still doing things it has no business doing, still the only aircraft that can do the job.